Two new studies and alarming headlines at the supervolcano Campi Flegrei in Naples, in Italy. That is not good. One study says there is an acceleration with deep magmatic input, and the supervolcano is moving towards a critical mechanical threshold. The unrest at Campi Flegrei, they say, is not simply growing at a normal exponential rate. They say it follows a faster, nonlinear acceleration pattern called a finite time singularity. Which means, in simpler words, the system is moving towards a critical transition until 2030. Wait a minute, we have 2026. That is soon. Accelerating unrest at Campi Flegrei signals a critical transition. This is one of the headlines that we're just seeing coming out of new scientific papers. I'm reading you another one. A transition may be coming for a massive Italian supervolcano. Campi Flegrei, a volcanic caldera near Naples in Italy, is speeding towards a transition, a new study suggests. So many headlines now in the news. This thing is going to blow. It's going to erupt way sooner than everyone expects. And this is a super volcano with many people living on top of it. That's why we need to clarify what's going on at the moment, because especially in light of the America's Cup that is happening in Naples in September, which according to their own evacuation plans adds to congestion and so many more people. So is everything that we thought wrong? We have a new study about where the magma is that shows us something very interesting as well. And guys, I just said it yesterday, a few days ago, the earthquakes that are happening. This came out of surprise. 4.4 in the water, shaking basically the whole coast there of Naples. And since then, we have more earthquakes. The 4.4 shortly followed by a 1.2, 2.1, and then 1.9 on the 23rd, a 1.7 on the 23rd, on the 24th, a 1.3, and right now a 1.6 at Vesuvius. We have talked about Vesuvius also quite a bit because Naples, greater Naples area, more than 6 million people, is squeezed in between Vesuvius and Campi Flegrei. So are they sharing something? What science is this, guys? Let's dive into this. This is important information. The headlines about Campi Flegrei are getting darker right now, and they're saying basically the supervolcano, the supervolcanic system of Campi Flegrei, the Phlegrean fields in Italy, could reach a tipping point within the next 10 years. And important is within, not in 10 years, right? Within always means tomorrow could be a possibility. Of course, in 10 years could also be a possibility. And another study says Campi Flegrei is accelerating towards a critical transition. What is it transitioning into is the question that you have probably right now. And then another says an eruption could be on the way. And again, this is not just any volcano. This is this giant restless caldera that looks like meteorites or bombs were hitting the area west of Naples in Italy, towns sitting inside the volcanic system, and hundreds of thousands of people living in the immediate red zone, the immediate danger zone. So when the headlines like this appear, people pay attention. We all are paying attention. But then something very important happened, and that's also interesting because we have the scientific studies and papers on the one side that have produced these headlines. But then today something comes out of the INGV, that's Italy's official volcano monitoring institute. And there has been some tension between scientists and the INGV. The INGV's own scientists said, well, guys, I think we should at least evacuate the red zone. There's more danger than you're saying, actually. And that raises doubts. Okay, are they telling us everything? Or do they just want to keep everyone calm because of real estate development, real estate values, businesses that are coming to the area? Because now they have pushed back against these releases and these studies which is very, very interesting. They said, well, one study is just preliminary. It's still under scientific review. Well, it has been published, right? So they said it's also not a deterministic prediction. Yeah, they always say, we're monitoring the system, and their own scientists say, well, monitoring doesn't guarantee you safety. So what's behind that? We have to unfilter this. We have to find what's really going on, I would say, right? Because they stressed the studies do not mean an imminent earthquake or eruption is being forecast. Yeah, until it's happening, right? You can't forecast that, but you can look at the scientific studies and the scientific data. And that's what these studies are actually doing. And then you have to interpret them. So the obvious question is this. Are these headlines exaggerating the danger? That is the real question. Or are the officials trying to prevent panic in one of the most complicated evacuation zones on Earth? In Europe, definitely. So that question is uncomfortable, guys, I know. But this is exactly where the real story begins that we have to look at too. Because the answer is not simply Campi Flegrei is about to erupt, right? And it is also not nothing is happening. That's the fine line that divides it. So the truth is definitely more tense than that. And yes, some of the headlines may be too direct. The INGV may be right to correct them, I would say, to some degree, because the volcano is still rising, the earthquakes are still happening, and the hydrothermal system is still under pressure. Everything is increasing. We see that in the INGV's own monthly bulletins. So, of course, that new study that has been released raises the serious question in our heads, is Campi Flegrei moving towards a new threshold, even if no one can say exactly what happens when it gets there? So this is where we have to separate three things, guys. The first thing is the media panic. The second thing is the official caution. And when I'm talking about media panic, I'm talking about newspapers, local releases. I'm not talking about these AI slop channels that are popping up everywhere, AI voice, and that are telling it's blowing, it's this one, and they're showing. Don't listen to this. Again, I have to say, because this is an epidemic. AI voices now really sound like real people. But if a person never shows their face, them being alive, not a photo. Even that, I mean, they're impersonating me right now, and it looks pretty real. Ask these channels to make alive, where you hear that voice and actually see them. None of them will be able to do that. So be careful. So official caution is the second thing. And the third thing is the volcano itself. Media headlines want a clean story, eruption coming, disaster warning, countdown to catastrophe. We know that. Officials, they want the exact opposite. Calm language that leaves doors open, right? No panic, no definitive claims that cannot be proven. But volcanoes do not care about headlines or press releases. We've seen this with many volcanoes in the past. So they follow pressure, heat, gas emissions, magma, fractures, and the strength of the crust above them. And the last one, we know the crust above Campi Flegrei is heavily damaged and weakened like never before, and especially at Campi Flegrei overall, all those things matter right now. The INGV, I want to make that clear too, is also not saying Campi Flegrei is safe, right? So they're saying this one study should not be treated as a prediction of an imminent eruption. And here's the wording imminent, right? So this is a very different statement. And that matters because if people hear like the tipping point between 10 years, they may think scientists may have predicted that exact date of an eruption. They have not. But if we hear the INGV push back, they may think the danger is fake, and it's not. It's not fake either. That's the thing. That is the tension, and the warning may be uncertain, but the unrest is absolutely real. I'm not saying the INGV is lying, but I'm saying their job is not only science. It's also public risk communication. And in a place like Naples, one badly misunderstood headline can create fear before the science is ready. So what does the study actually say? That's the interesting part. Not what the headlines are saying. We will look into that. This study says the system may now be speeding towards a critical transition. Speeding and critical transition are the key words here. And the dangerous part is this. The scientists do not yet know whether that transition means an eruption, a peak in the current unrest, or a deeper change inside the supervolcano, because this is happening under one of the most densely populated volcanic danger zones. It's not a normal cone-shaped volcano like Mount Vesuvius. It's a giant volcanic caldera, basically a collapsed volcanic system, roughly 10 miles, 15 kilometers across. And parts of the city of Pozzuoli are inside. More than 500,000 people live in the wider red danger zone. And now two different scientific stories are coming together at the same time. One study is looking at the deep magma system underneath Campi Flegrei. The other is looking at the speed of the unrest itself. And together, they make the situation way harder to ignore. Because the question is no longer, is the ground rising? The question is now, why is it rising? What's feeding it? And how much longer can the crust keep taking this pressure? Campi Flegrei has been under unrest since 2005. That means for more than 21 years, the ground has been lifting up, the earthquakes have been shaking the area, gases have been rising, and the hydrothermal system underneath the Solfatara and Peschiarelli has been heating up and pressurizing. That's often called bradyseism, right? The word sounds slow and almost harmless, but what is happening now does not look like a simple, slow breathing of the ground. Not at all. The deeper picture suggests a volcanic system is being fed from below. And this new study has looked beneath Campi Flegrei. They have used seismic waves from more than 500 distant earthquakes. That sounds technical, but the idea is simple. When earthquake waves pass through the earth, they change the speed when they hit different materials. So solid rock behaves one way, but magma, partially molten, weakened rock behaves differently, like a gluey mass, right? Waves can't travel that fast. And what researchers now found under Campi Flegrei is not just one simple magma chamber. They found a multi-level system. It's deep below the caldera. Now we talk about the deeper system. We know there's a lot of magma batches higher up, and we've seen studies about that. But now the deeper system, it's between 16 and 33 kilometers down, roughly 10 to 20.5 miles. They have identified a zone where seismic waves slow down. And that is important because low seismic velocity can point to hot rock fluids or magma. So they say that in parts of this deep zone, the melt fraction could locally reach about 30%. So that does not mean there is a giant empty cave full of liquid magma. That is not how these systems usually work, but it does mean the volcano may have a deep, hot, partially molten source zone that can feed gases, heat, and possibly magma upwards over time. And above that deeper zone, the researchers also found hints of a possible transport area, and that doesn't sound good, between about 10 to 16 kilometers deep, around 6 to 10 miles, plus a possible accumulation zone around 8 kilometers or about 5 miles below the surface. And that accumulation zone has been confirmed with other studies in the last 2 years. They say it's even more shallow, like roughly 4 kilometers, right? So roughly 2 to 3 months. So this is not just a shallow steam problem that is happening here. The new picture is way more disturbing. Campi Flegrei may be a connected system, deep magnetic input below, fluids moving upwards, pressure building in the hydrothermal system, and the brittle crust above being bent, cracked, and shaking. Because often we think, oh, that's just hot water and steam coming out of these fumaroles, right? The shallow damage may be happening in the hydrothermal system, but the energy source appears to be deeper and magmatic. That's the first major point, but now comes the second one, guys. A new separate study looked at the acceleration of the unrest, and this is where it really becomes dangerous, more dangerous and interesting. The authors studied the earthquake activity and the ground deformation and asked, is Campi Flegrei simply becoming more active in a normal, gradual way, or is the acceleration itself accelerating? So that sounds like a small difference, but it is huge. Imagining a car going faster, that is one problem. But now imagine the car is not only going faster, the rate at which it speeds up is also increasing, and that's a different kind of problem. So this study suggests that Campi Flegrei's unrest is better described by what scientists call a finite time singularity. So that means the system may not be moving in a straight line. It may be moving towards a threshold, a breaking point. So not necessarily an eruption tomorrow, not a guaranteed catastrophe, but a point where the current pattern cannot continue in the same way forever. Okay, it cannot continue in the same way forever. So the study's independent analysis points towards a possible critical time window around 2030 to 2034. That's not a date for an eruption, guys. It's also not a doomsday clock, but it is a warning that if the current trend continues, the system may be forced into a different state within the next decade. And that different state could, of course, be several things. It could be an eruption. It could be a peak in that whole Brady season where the system releases pressure without erupting. It could be a change in the internal plumbing of the volcano where gas, fluids, or magma move into a new pathway. But the key point is this. The new study says the outcome remains uncertain. And uncertainty is exactly what makes Campi Flegrei so dangerous, because this volcano does not need to produce like a giant super eruption to create an absolute disaster. A much smaller eruption inside a populated caldera could still be absolutely devastating. The last eruption was Monte Nuovo in 1538, and that eruption has built a new cone in just a few days. It was not the biggest eruption of Campi Flegrei, and not the biggest one that Campi Flegrei is capable of. But in today's world, with modern towns, roads, homes, schools, hospitals, and hundreds of thousands of people in the danger zone, we have to make it clear, even a smaller eruption or explosive eruption, phreatic eruption would be a major emergency. And that's why scientists watch the crust. The crust above Campi Flegrei has been stretched again and again. We had these unrest episodes in the 1950s, 1970s, 1980s, and now the current one since 2005. Each episode matters because rock remembers stress, and it can be damaged, weakened, cracked, and pushed closer to failure, and that's what happened here, right? So, of course, not every earthquake swarm is like the final warning, but it does mean the system today is not starting from zero stress, right? It's building on decades of deformation, and since 2005, the ground has been risen dramatically. The latest reporting says the caldera floor has risen roughly 1.6 meters, that's 5 feet, something like that, during the current unrest phase. And we also show continued uplift. And the geochemistry that is happening at the caldera right now is important. We have a long-term heating and pressurization trend of the hydrothermal system. At the Solfatara area, the BG Fumarole has an average temperature of 170 degrees Celsius. That is about 343 degrees Fahrenheit. This is like an oven. You can bake something in it, right? At Pisciarelli, carbon dioxide flux remained within the longer-term increasing trend. And every bulletin we get from the INGV confirms hydrothermal system still showing signs of heating and pressurization.
There is a fault line hiding off the coast of British Columbia, and right now it is pushing 12 million people toward the worst disaster in Canadian history. Cascadia, the 1,000-kilometer crack in the seafloor that almost no one in Vancouver has ever heard of. For 325 years it has been silent. For 325 years it has been loading. And the data the British Columbia government quietly published in 2025 in a report that should have been on the front page of every newspaper in this province says the silence is ending. 3,400 dead, 10,000 injured, 18,000 buildings destroyed. Losses greater than every natural disaster in BC history, combined 1 in 5 chance it happens within the next 50 years. That is not a forecast. That is a published government number. And scientists are no longer using the word possible to describe it. They are using the word inevitable. A brand new April 2025 study published in the Proceedings of the National Academy of Sciences found that when the rupture comes, the BC coastline will drop by up to 2 meters in less than a minute. Permanently. The ocean will move inland. The flood zone will double. And it will stay that way for the rest of the century. The headlines did not cover this. The province has not adjusted its messaging, and the official advice for what to do in your home is still based on a 72-hour kit. So the real question is this: why is the government's own modeling telling them one thing and their public advice telling you another? This is the story of the 6 minutes scientists described as inevitable, and what those 6 minutes will actually do to Vancouver. There is a drive you can take out of Vancouver that will tell you everything you need to know about what is coming for this coast. Head west on Highway 99, then north on Highway 4, all the way across Vancouver Island until the pavement runs out at the Pacific. Park anywhere along the tide line at Tofino. Wait until low water, and then look down. Walk far enough out, and you will see them. Dead trees. Standing upright in the salt mud, dozens of them root-locked into the seafloor, not fallen. Standing. Some of them are 12 meters tall. Most are stripped of bark, bleached pale gray by the Pacific. They look wrong because they are wrong. Forests do not grow in salt water. These ones did, once. These are the ghost forests of the BC coast, and they have been standing in the tide for 325 years. The night they died was January 26th, 1700. Around 9 o'clock at night, the Cascadia Fault ruptured along its entire length. The shaking lasted 6 minutes, and in those 6 minutes, the coastline of what is now British Columbia dropped 2 meters into the ocean in a single motion. The trees were 100 meters inland one night. By morning, they were standing in salt water. They died where they stood. Within months, the bark fell off. Within years, the canopy was gone. But the trunks did not fall. The salt cured them. The mud held them. They have been there for 3 1/4 centuries, marking the high water line of the last time Cascadia tore. That is the fingerprint. That is the proof. And until 1986, almost no one in Canada knew it was there. For most of the 20th century, scientists believed Cascadia was dead. Not asleep. Dead. The plate boundary on the maps was clearly going down somewhere, but no major earthquake had ever been recorded on it. So the working assumption was that it slid silently, that British Columbia and the Pacific Northwest were safe. The building codes for Vancouver and Victoria were written on that assumption. Schools were built on it, hospitals were built on it, bridges were built on it. An entire civilization grew on top of a fault that the science of the day said did not exist. Then a geologist named Brian Atwater walked into a salt marsh near Tofino in 1986 with a steel soil corer over his shoulder. He was 35 years old. He worked for the United States Geological Survey. He was looking for ghosts. He drove the corer into the marsh. He pulled up a column of dirt, and inside the dirt he saw the answer no one had been looking for: a layer of clean gray sand. On top of a layer of dark forest soil, on top of a buried tree stump that was still upright, still rooted in place, but dead. The only force in nature that lays a smooth sheet of sand on top of a standing forest is a tsunami. The only force that drops a coastal forest 2 meters into the salt zone in one night and kills it where it stands is a megathrust earthquake. He had just found the fingerprint of Cascadia's last rupture, buried under his boots. He spent the next decade walking marsh to marsh up and down the BC and Washington coasts. He pulled up the same fingerprint in 8 different places, 8 Cascadia ruptures. The average interval between them was 240 years. The last one was 325 years ago. That is the math. That is why the word inevitable is being used. Cascadia is overdue, 85 years overdue on its own average cycle. Quick thing. If you knew before today that the ground under Vancouver had already dropped 2 meters in a single night, and forests are still standing in the salt water to prove it, drop a comment. Curious how many people actually knew this. Picture this. The Juan de Fuca plate, the one diving under British Columbia, is at roughly 4 centimeters a year. That is the rate at which a human fingernail grows. Now imagine fingernails growing on every square kilometer of seafloor between Tofino and California. For the past 3 centuries, all pushing in the same direction, all locked at the boundary, all building stress that has nowhere to go. 325 years of locked fingernails. That is the number a Vancouver resident should be carrying around in their head. And the section of the fault directly off the coast of British Columbia, the section closest to Vancouver and Victoria, is the section a 2024 study in Science Advances identified as the most likely to break next. Smooth, flat, locked, loaded. The geometry of it is exactly the geometry that produces clean, long, full-length ruptures. But the most terrifying part is not even the earthquake, it is what we have built on top of it. The headlines you have seen for the past 20 years have mostly used one word. Possible. Possible megaquake. Possible big one. Possible disaster. The headlines were technically correct in 1995. They were still mostly correct in 2010. They are not correct now. The 2024 Science Advances paper, the 2025 BC Government Report, the April 2025 PNAS Subsidence Study, all 3 of them published in the last 24 months, have moved the science from possible to expected. They have moved it from if to when. And nobody has translated that shift into the kind of plain language the public actually hears. So here is the plain language. The fault is loaded. The geometry favors BC. The next rupture is most likely to be the full one. And the city directly in its path is built on a 200-meter thick trampoline. If you're following along and not subscribed yet, that's on you, but I'd appreciate it. This channel is mostly about the BC stuff nobody else is connecting. To understand why Vancouver in particular is in such trouble, you have to understand the kind of dirt the city is built on. Most of Greater Vancouver, including the entire Fraser River Delta, sits on something called unconsolidated sediment. 200 meters of sand and silt and clay, dropped there by the Fraser River over the last 10,000 years, sitting on top of bedrock buried far below. Now picture this. When the seismic waves from a Cascadia rupture arrive at the lower mainland, they will travel through the bedrock fine. But the moment those waves hit the soft sediment above it, they slow down. And as they slow down, they grow taller. They get bigger. They amplify. Imagine the difference between jumping on a hardwood floor and jumping on a trampoline. Same energy, bigger motion. Vancouver is built on the trampoline. It gets worse. During a magnitude 9 event, the saturated layers of that sediment do something even more dangerous. They lose their strength entirely. They liquefy. The ground becomes the texture of thick, wet concrete for a few seconds. Anything built on top of it sinks, tilts, or topples. Vancouver International Airport sits on a liquefaction zone. Most of Richmond sits on a liquefaction zone. The Port of Vancouver, the Tilbury LNG facility, the Fraser Bridges, the Tsawwassen Ferry Terminal, all of it is built on ground that will not behave like ground for those 6 minutes. And then comes the part of the story that almost no one in Vancouver has heard. In April of 2025, a research paper was published in PNAS. The title was bureaucratic. The content was not. The lead researchers, including Dr. Tina Dura of Virginia Tech and Dr. Andrew Garner of Rowan University, took the standard Cascadia scenario and added one variable: subsidence. When a megathrust earthquake ruptures, the coastline does not just shake, it drops. The crust along the BC shore has been pulled upward over centuries by the locked fault below. When the fault releases, that upward pull releases too. The coast drops. The 2025 paper modeled it for the entire Cascadia margin. The answer it produced was somewhere between 0.5 meter and 2 meters, in less than a minute, permanently. Let that sink in. The land does not bounce back the next morning. It stays down. For decades. Whatever floods on day one stays flooded as the new normal. For Vancouver, the subsidence is not as much about open coast inundation as it is about Richmond. Most of Richmond sits between 0 and 2 meters above the high tide line. Think about that. Half of an entire city, with 230,000 people in it, sits at the height of a normal kitchen counter above the Pacific Ocean. The dike system that keeps the Pacific out was engineered for a particular sea level. Drop the base elevation by even 0.5 meter in 60 seconds, and large sections of the Richmond dike system become structurally compromised on the same afternoon as the earthquake. This is not a future problem. This is not a 50-year problem. This is a single day. The shaking ends, the dust settles, and then the tide comes in. The 2025 PNAS modeling was the first study to combine the shaking, the subsidence, and projected sea level rise into one integrated scenario. The conclusion: the number of people, buildings, and roads exposed to coastal flooding more than doubles after the earthquake. That is one sentence in a peer-reviewed paper. It is also why the BC government's casualty count is what it is. Now imagine you are in downtown Vancouver. It is a Tuesday morning. You are in a meeting at a building on West Hastings. You are riding the SkyTrain across the Campi Bridge. You are walking your dog along the Stanley Park seawall. Here is the part that almost no one warns you about. The shake will not feel like an earthquake, not the kind you have seen in movies. Movie earthquakes are short and violent. A magnitude 9 megathrust is the opposite. It rolls. It builds. It does not stop. The seismologists describe it as a slow, deep rolling motion that grows for 2 full minutes before it peaks. You will not feel a sudden jolt. You will feel something is wrong. Then you will feel it more. Then the building will start to move with you. Whatever you are doing, at the first instant of the rupture, you feel a sharp jolt. Then a brief pause, then a slow rolling motion that does not stop. Within 10 seconds, you cannot stand. You are watching glass fall out of skyscrapers 2 blocks away. The shaking continues. 40 seconds in. The parts of the city built on soft soil, Yale Town, parts of False Creek, the airport Richmond Delta, are starting to fail. Older masonry buildings in the West End and Mount Pleasant begin to crack. 2 minutes in. Water mains have ruptured in dozens of locations. Underground gas lines are failing across the Lower Mainland. Power is gone. The cellular network is overloaded, and then it collapses. The SkyTrain is offline. Every bridge in the Lower Mainland is shaking at frequencies its 1960s and 1970s engineering was never tested against. 4 minutes in. The sediment under Richmond has liquefied. The runways at Vancouver International are deforming. Communications are dead. 6 minutes in. The rupture has finished. The shaking subsides. The city is standing. Mostly, but there is no power. There is no working water. There is no road network across the Fraser. The Massey Tunnel, opened in 1959 and never designed for a magnitude 9, may or may not be passable. The Lionsgate, the Pattullo, the Portman, the Ironworkers, all built or upgraded to different codes, and not all of them are expected to survive. And then, about 10 minutes after the shaking ends, the coast subsides. 0.5 meter. 1 meter. 2 meters. The dikes around Richmond, already shaken to their structural limits, are now also below the water they were built to hold back. It is February in Vancouver. The temperature is dropping below freezing tonight. The federal government's own internal modeling, leaked to the CBC in 2023, used 14 words that should have changed everything about how this province talks to its residents. Post-disaster supply chain may not be functional for 7 to 14 days. Read that again. 14 days. The standard guidance from Emergency Management BC is to keep a 72-hour kit. 72 hours is 3 days. The federal modeling says 14. That is not a small difference. That is the difference between a household making it through with what they have on the shelf and a household running out of water on day 4. So why does the official advice still say 72 hours? Because telling 3 million people in the Lower Mainland that the guidance they have been operating on for 20 years is wrong by an order of magnitude is not the kind of thing any provincial government has been willing to say out loud. The 72-hour number was originally based on the post-Kobe Japanese emergency model. It was always understood by emergency managers as a minimum, not a recommendation. The Federal Review in 2023 contained the sentence that should have replaced it. But replacing it would have meant a press conference. And a press conference would have meant headlines. And headlines about a 14-day kit would have moved real estate prices in Richmond. So the kit guidance stayed at 72 hours. The modeling moved to 14 days. And the gap between them is the gap between what the public knows and what the public would need to survive. And it is not just the kit number. The province has not built a centralized, hardened emergency stockpile. The supplies it does have are distributed across warehouses, some of which sit in the same liquefaction zones as the people they are meant to serve. The Massey Tunnel replacement, which was supposed to fix the single most vulnerable river crossing in the Lower Mainland, is still under construction and will not be ready in time if the rupture happens this decade. The seismic upgrade program for the older masonry schools in Vancouver has been talked about for 20 years and is still incomplete. The Federal Interagency Volcanic Event Notification Plan, the framework for how Canada responds to large seismic and geological emergencies, was written in 1990 and has not been substantively rewritten in 36 years. These are the facts on the ground. Cascadia is loaded. The province knows. The federal government knows. And the system you are relying on, if you live in Vancouver, was built by people who did not have the science you have access to in 2026. Honestly. If you know someone in Vancouver or on the island, low-key send this to them. 5-second thing that might actually matter to them. Now there is the tsunami. And this is the part where the geometry gets really cruel. A magnitude 9 Cascadia rupture generates a tsunami that reaches the outer coast of Vancouver Island in 12 to 15 minutes. 12 minutes. That is the time it takes to boil pasta. Tofino, Ucluelet, Bamfield, Port Renfrew. All of these communities sit between 5 and 10 meters above sea level. The expected wave height on the open coast is between 8 and 12 meters, taller than the building most of those residents work in. There is no warning system on Earth that can move a population to high ground in 12 minutes. The shaking itself has to be the warning. Emergency management. BC's actual advice is brutal in its simplicity. If you feel strong ground shaking on the West Coast that lasts longer than a minute, you do not wait for a siren. You do not wait for a phone alert. The moment the shaking stops, you have 10 to 15 minutes to move the ground at least 20 meters above sea level or 3 kilometers inland, whichever you reach first. Greater Vancouver and Greater Victoria are partially shielded from the open Pacific tsunami by the geometry of the Strait of Juan de Fuca, but they are not shielded from seiches. A seiche is what happens when trapped water in a semi-enclosed basin starts sloshing, like a bathtub that has been pushed. The water piles up at the narrow ends. Burrard Inlet, Howe Sound, Indian Arm, False Creek. All of them are candidates. The Stanley Park seawall sits at 4 meters above the high tide line. The credible seiche scenario for inner Burrard Inlet is 6 to 8 meters. The math is not subtle. So here is where you are. You live in a city built on a trampoline. You sit 200 kilometers from a fault overdue by 85 years on its average cycle. The provincial government has published the casualty numbers. The federal government knows the supply chain will fail for 2 weeks. And the brand new science from April 2025 says when the rupture comes, your coastline drops a meter in a single minute and stays down for the rest of your life. If you live anywhere on the BC coast, in Greater Vancouver, or in Greater Victoria, the things that actually save you are unglamorous. And they take 1 weekend, 14 days of water. Not 72 hours, 14 days. Anchor your bookshelves, anchor your water heater, strap your hot water tank to the wall studs. Pick a meeting point with your family that is 20 meters above sea level or 3 kilometers inland. Tell them the rule. The shaking is the warning. Keep a pair of closed-toe shoes under your bed. Broken glass after a megaquake is the leading cause of secondary injury. People who survive the shake and then walk barefoot through their bedroom on day 1, or who fill the ERs on day 2. Know which of the bridges between your home and your job was upgraded after 2005, and which one was not. That information is public. Almost no one looks it up. None of this will save you in a worst case. But all of it improves your odds dramatically in the more probable scenarios. And probable matters now, because probable is no longer hypothetical. The 1,000-kilometer fault has not ruptured in 325 years. The average is 240. The section closest to BC is the section most likely to break. The next rupture will be approximately magnitude 9. It will shake for 6 minutes. It will drop the coast by up to 2 meters in less than a minute. It will damage 18,000 buildings. It will injure 10,000 people. It will kill 3,400. It will exceed the combined losses of every natural disaster in BC history. It will leave the lower mainland on its own for 2 weeks. Its probability of occurring within your lifetime is between 1 in 5 and 1 in 7. And the official household preparedness guidance is still 72 hours. These are not numbers from a forecaster. They are numbers from the province's own 2025 report, from peer-reviewed papers in PNAS and Science Advances. From federal modeling the CBC obtained in 2023, the data has converged. The science has converged. The only thing that has not converged is the public conversation. The ghost forests are still standing, salt-killed, root-locked, 325 years old. They mark the high water line of January 26, 1700. There is room in the tidal mud for a new line. The instruments off Vancouver Island are watching it form right now. So whose street does it reach? The one that stops at Tofino, the one that climbs into Victoria, or the one that walks in 6 minutes flat into the streets of downtown Vancouver? If you made it this far, you probably found something worth knowing. Most people forget to subscribe after the ending. So, there's your reminder.
From city council meetings to graduation ceremonies to offices and bedrooms, an earthquake shakes the ground from Ottawa to Buffalo and beyond. News 4's live team coverage starts right now.
In the very roots of the North American craton. Then came the shocker. INSAR satellite scans from NASA revealed faint linear deformations beneath Lake Superior and Lake Huron. Subtle ridges and depressions stretching for nearly 250 miles. What makes this alarming is that those features align almost perfectly with the ancient mid-continent rift, a billion-year-old scar that once nearly tore the continent apart. For decades, geologists called it dead, extinct, a relic of Earth's distant past. But if it's dead, magnetic readings show unusual conductivity beneath the rift, the kind of signal produced by molten material or heated fluids. Some researchers now suspect thermal reactivation, magma seeping into long dormant cracks far below the surface. This kind of process isn't fast, it's geological slow motion, but that's what makes it terrifying. The crust under the Great Lakes is thick and brittle. If it starts to bend or flex even slightly, the stress could accumulate for years before releasing in one catastrophic rupture. Communities along Duluth, Thunder Bay and Sault Ste. Marie are now being quietly advised to prepare for rare seismic activity. Experts are installing new deep earth monitors, but they admit one thing: no one fully understands what's happening. Are now being reshaped by fire from below, then what other stable parts of our planet might be hiding the same silent danger? Chapter 2. The Rift That Refuses to Die. They said the rift was ancient history, but history has a way of repeating itself. Deep beneath the peaceful waters of Lake Superior, the mid-continent rift system still cuts through the continent like a buried scar, stretching from Kansas to Ontario, nearly 2,000 kilometers long. It's the wound that almost split North America in half a billion years ago, before it mysteriously stopped. Now that scar is stirring again. In the past 6 months, GPS satellites have detected subtle uplift patterns around the western shore of Lake Superior, up to 4 millimeters per year, a shocking rate for a supposedly stable continental interior. Even more disturbing, the uplift mirrors what scientists call a mantle swell, a bulge of heat rising from deep inside the Earth's crust. Thermal readings from magnetotelluric surveys show anomalous energy fields under Duluth and Thunder Bay. Electromagnetic activity too high to be caused by groundwater or mining. The data points to molten rock still circulating beneath ancient lava flows. It's as if the Great Lakes are sitting on top of a sleeping volcano, one buried so deep we forgot it was there. And if the rift starts spreading again, even a few centimeters of movement could destabilize the entire region. Dams, bridges, pipelines, all built on the assumption that the ground beneath them never moves. If the continent once tried to tear itself apart here. Chapter 3. The Lake That Breathed. It started as a whisper beneath the waves, and ended with the impossible. At first, no one believed the instruments. But then, in early March, the water itself began to move. Sensors stationed across the Lake Michigan basin picked up something no one had ever seen before: a rhythmic, low-frequency rise and fall of the lake's surface. Every 30 minutes, the water level surged upward, then sank again, as though the entire lake were breathing. Locals along Wisconsin and Illinois watched in disbelief. Docks groaned, boats strained against their lines, and waves appeared even on windless mornings. Fishermen thought it was a passing seiche, a harmless oscillation caused by shifting air pressure. There was no wind, no storm, no pressure change, and yet the pulse continued, slow, steady, and eerily synchronized. Then came the real shock. The pattern matched the deep tremor cycle recorded beneath Lake Superior just days earlier. That's when scientists realized what they were really seeing. The Great Lakes weren't acting independently. They were moving together. Using advanced INSAR satellite mapping and hydroacoustic sensors, researchers discovered a strange, wave-like energy ripple traveling through the bedrock, from Superior to Michigan, then down toward Huron and Erie. The signal repeated at exact intervals, suggesting a shared geological heartbeat. "The lakes are breathing in unison," one NOAA scientist admitted in a leaked internal memo. "It's not a local phenomenon, it's continental." This revelation has sent shockwaves through the scientific community. For decades, the Great Lakes were believed to be isolated basins, carved by glaciers and stabilized long ago. But the new data tells a darker story, that beneath the calm waters lies a massive, interconnected fracture network, still alive with geological tension. If one basin moves, they all move. If one cracks, the chain reaction could travel across half the continent. The USGS has since expanded its inland deformation alert systems, quietly setting new thresholds for crustal oscillation events. Insiders suggest they're preparing for a larger regional shift, one that could reshape shorelines and destabilize river systems feeding into the Great Lakes. Is it possible that what we're witnessing is the reawakening of the mid-continent rift? If so, this breathing may not be harmless at all. It might be the first deep inhale before the Earth exhales with devastating force. And if that pulse grows stronger, what happens when the Great Lakes breathe out? Chapter 4. The Heat Below It. Started as a whisper on the data feeds, a faint, almost invisible rise in ground temperature readings from Michigan's Keweenaw Peninsula. No one noticed at first, but within weeks, the whispers turned into alarms. Infrared satellites, orbiting quietly hundreds of kilometers above Earth, began detecting something impossible. Long, thin streaks of warmth glowing faintly beneath the surface of northern Michigan. The data didn't lie. The Earth beneath the Great Lakes was heating up. At first, analysts dismissed it as sensor noise or surface interference, but as the readings persisted, day after day, week after week, the truth became undeniable. A hidden thermal anomaly was spreading along the same scar that defines the mid-continent rift, the billion-year-old wound that once tried to split North America in two. In the satellite imagery, it looked like a glowing vein, a pulse of energy running directly beneath Lake Superior and radiating west toward Minnesota and east into Ontario. The rise in temperature wasn't massive, only a few degrees Celsius, but its consistency terrified geophysicists. This was no random fluctuation. It was organized, rhythmic, alive. When universities across the Great Lakes region began cross-checking data, The pattern held up. Borehole thermometers confirmed it. Ground-based infrared scans matched it. It's as if something deep underground just turned back on, one geologist said in a confidential briefing. Some tried to explain it away as residual hydrothermal circulation, leftover heat moving through old fracture zones, yet the energy output was far too high, rivaling levels recorded near active volcanic zones. That's when a darker theory emerged. Mantle convection may be reactivating beneath the mid-continent rift. In simple terms, magma might be on the move again. The implications are staggering. It could reawaken ancient volcanic systems buried deep beneath the Great Lakes. The last time this region was alive, over 1 billion years ago, rivers of lava poured across an area larger than Texas. Entire mountain ranges formed and collapsed in fire. Now, that same geological furnace appears to be flickering back to life. Already, small microquakes have been recorded near Thunder Bay and Duluth. Subtle, pulse-like vibrations echoing through the old Rift Valley. Some experts fear they could be the early signs of renewed magmatic pressure. The same kind of precursor activity seen before eruptions in Iceland and Hawaii. Government agencies haven't gone public, but leaked internal memos suggest the US Geological Survey has quietly expanded its thermal anomaly watch zones across the upper Midwest. If this continues to spread, the calm blue waters of the Great Lakes may one day hide something extraordinary or catastrophic. Because when the Earth's deepest furnace turns on again, it never does so quietly. Chapter 5. The Crumbling Shorelines. While scientists study the deep, everyday people are beginning to notice the signs right in front of them. It started subtly, a small crack zigzagging across a lakefront road in Duluth. Then another appeared outside Sault Ste. Marie. Before long, entire seawalls began to buckle, and marinas, once perfectly level, started to tilt ever so slightly toward the water. What at first looked like routine frost damage has now turned into a chilling mystery, spanning hundreds of miles.
I took this picture in 2015. That was a year I was taking a lot of them, and it was just at random, and I would, like I'd be at a red light or a stop sign, and I would just put my hand up, out of the window, and I would just snap a picture, and that would be it. So I would, feel moved to do that, or it was just spontaneous, right? And I was doing this for the between 15 and 2017, I think, was the last time I snapped pictures like this. But there was a difference, and it's this picture here that is holy. It is this picture that was different than all the other pictures that I have shown and that I haven't even shown yet. There's much more. But this one was different. It was the only one. In 2015, the family and I, we were doing the yard. It was really a beautiful day, and I'm sitting at the table, and I hear, "Take a picture." There's nobody around me, nobody's behind me, beside me, in front of me, there's nobody there, but I hear very clearly, "Take a picture." So I get up and I start walking, and I'm thinking, what should I take a picture of? I don't know what. So I took a picture of my cat. Went back to the table, put it down, went and did the yard work. Came back, sat down, and I heard, "Open it up." I'm thinking, open what up? I had forgotten all about the picture. So I'd like you to understand, before I go further, that this camera, that this phone that I had was a small Samsung back in 2015, and it had a great camera on it. I've never had a camera like that ever since. And I was able to open up the pictures real wide compared to the newer brands that were coming out. They couldn't open it up as wide as I could. So this camera was really beautiful camera to do that. So I slowly started to open up, and the first thing I see is Jesus standing there with his arms up and an angel behind him, his head bowed on his knees with his arm over his knee with a cross behind him. Behind him, there's another angel with wings standing with his leg like looking on a step, looking into a screen. This is the first thing that I see when I see this. I just froze. I didn't know what to think. I couldn't. I was just numb. I couldn't. Why me? Like, why? I couldn't believe it. Like, I mean, I'm not a church-going person. I'm not involved in the community, you know. So, wow. I mean, this scared me, you know. Didn't feel worthy of this at all. So as time went on, I would look at this and discern the picture. Now, Jesus, when he came to me, he always gave me a vision. And a vision, but with prophecy is what I mean to say here, because in this picture here, there is prophecy. So I started looking at the stone, and it was Jesus who brought this stone that he is standing on. This is not my roof, but this stone is on top of my roof. There's no tall building beams behind me or beside me. This is what Jesus brought with him. And then there's the boot. Now that one baffled me. I couldn't figure that one out. I'm going, what would the boot represent? What does it symbolize? What's going on? So again, I didn't know until later that Italy was in the shape of a long-legged boot. So I'm thinking, could this be the country? Could this be Italy? Not thinking much of it, and I put it on the shelf, keeping an eye on Italy like I did with the fires and that, but again, stayed on the shelf. Until I met this woman that you had just watched. And what is she talking about? She's talking about Italy. What is she talking about? She's talking about earthquakes, volcanoes. And then that brought me right to the dream that I received in 2016. In 2016, the first part of the dream, there was 3 parts to it, just as it was given to me in 1975. And the first part, we're just descending from the mountain. And I'm driving, and I look over to my left, and I see 7 volcanoes, mountains with fire on top. There's 7 of them. And I assumed that this would be countries, 7 countries. And then it stopped. This is why I thought this was important also to bring to the table and to be reminding you that 10 years is not too far away from us. Major changes are happening. The earth is moving, and like that one man said, It's like they're breathing. The water is breathing. Well, that's all I'm going to say for now. But this is, I believe, a real true warning. And we should heed this warning. And those that are in those zones, the danger zones, should hear this loud and clear. So I truly believe that, yes, this is the boot, and I believe it is Italy. Okay. Gotta go. Thank you, Jesus. May your peace be within. No fear, be love, and give hope.